Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to look back at the predictions I made for 2021. Let's see how well I did right after this. The areas that I kind of chose to look at were CPUs by AMD, ARM, and Intel, and then look at GPUs by AMD, Nvidia, and Intel. And then I made some predictions about software. So let's just dive in and see how things went. So the first one was with Threadripper. I thought Threadripper 4000 would be announced in 2021. Granted, there's another month left and at the time I'm making this video, but I don't think that's going to be likely, not with CES on the heels of December, so plus the holidays coming up. I just don't see this happening in 2021, and obviously it hasn't so far. As far as the Zen 4 architecture or Ryzen 6000, that also didn't materialize. As to what the reasons are behind it, I suspect there's a number of reasons for it. So mostly to do with demand for the 5000 series machines, as well as AMD's GPUs is occupying a lot of the capacity of the fabrication facilities to build those chips, plus supply chain issues in getting the other support chips that are needed in order to continue out the builds for the boards. So, yeah, I don't know all the reasons, but as are my guesses. ARM CPUs, Nvidia had tendered an offer to purchase ARM, and that was pending approval as of the end of last year. Well, that's all been taken care of, and Nvidia does indeed own ARM. I thought that Apple's move to Apple Silicon, which is an ARM-based design, would place more focus on ARM for both desktops and servers in 2021. That, in fact, has happened. Both on the desktop from the Mac OS desktop, as well as the servers from both Amazon, and there's a number of other providers like Ampere and so forth that are building server-size CPUs based on ARM. Qualcomm also released their Snapdragon 888 in 2021. And ARM had predicted to release the Neoverse Perseus. This is their N2 chip. This is based on ARM version 9. And so this is a 5 nanometer die. It's PCIe Gen 5. It can use either HBM3 or DDR5. And I said it would support 192 cores, but if I had bothered to read the spec, I would have seen that it actually said 128 plus was the intention. Now, there are some designs that go higher than 128. And but the spec doesn't specify that it can't go above 128. So anyway, it was close. It wasn't perfect. There's also the ARM Neo VS Zeus. This was announced back last year in the version last year being 2020. So yeah, those were announced last year. They are the scalable versions of the processor. Now there are SVEs, the scalable vector extensions that are installed in the N2, which is a general purpose compute chip. But this one is dedicated to doing vector operations solely. So yeah, and this has a much wider bandwidth. So 128-bit versus 2048 between the old versions and the new. Intel did release Rocket Lake. This is their 11th gen CPUs. In 2021, they had released the mobile versions of this machine earlier in 2020, and the mobile are, I believe, 10 nanometer, but the desktop, that they just couldn't get it to produce enough numbers to make the yields work. So they redid their designs for 14 nanometer fab, and that did create some problems. I mean, and they had to reduce the number of cores they had planned for the system. I think the TDPs were probably based on 10 nanometer because they almost doubled. And so, yeah, you would kind of expect that. So as far as the TDP is concerned, it's actually 125 watt, and that's max TDP. And then the Down spec for TDP, 95 watt is the normal on an 8-core part. The higher level TDPs never happen, and of course I think that's because we just didn't have the 10 core or 12 core models of the CPUs released. They just wouldn't fit on the die. On the clock, 5.3 and so forth, that was all set. Didn't know the speed of the memory at the time I did this. That turned out to be 3200 megahertz. And it does indeed have an XeLP graphics module that is now renamed the Intel UHD Graphics 750. But that is not the same. It is not even the same architecture as the previous models, like the 740 and 730. Not even the same category. So 12th gen or Alder Lake, that also released late in 2021. In fact, it was about a month ago at the time I'm making this video, that is. So that is a hybrid architecture similar to the big little designs of ARM. But this is Intel's. It is 10 nanometer. Intel doesn't call it 10 nanometer. They call it Intel 7. So I don't know if they're implying that it's 7 nanometer, but it isn't. It's 10 nanometer. There are models that support 4.8, and I said 16 core. Yeah, well, that's not exactly true. And 32 thread, that never happened either. So what actually transpired here is the 16 core is correct. However, 8 of those are performance cores, and 8 of those are efficient cores, as you all well know. Also, only the performance cores support hyperthreading. The efficient cores do not. So you get 16 total threads from the performance cores, and you only get 8 threads because it's only a number of cores you have on the efficient cores for a total of 24 threads. It is a 5.2 gigahertz clock. TDP is 125 watt up to 241 watt. I have seen some people measure that higher, but I guess that really depends on what how you define TDP, and there is some fairly wide latitude in how you define TDP. DDR5, I said, would support up to 4 gig transfers per second. It actually measures at 4.8. It also supports DDR4. Now, it says 32 gig. No, it's 3.2 gigatransfers per second. But this chip will operate either on PCIe Express 4 or PCIe Express 5. And Thunderbolt is wired to the slower of the two. So it is actually, you don't have Thunderbolt 5. There is a spec for Thunderbolt 5. But I believe it requires PCI Express Gen 5 exclusively in order for that to work. So, yeah, that's why it's still Thunderbolt 4, is because of support for the older Gen 4. It too has an Intel Xe-based GPU. This is the one that's inbuilt in the chip. And again, this is relabeled as the Intel UHD Graphics 770. I said that general comment, this was back in December now of last year, AMD had achieved dominance, which was true at the time with their 5000 series chips. Now, that's not true right now. I think Intel has clawed that back with the 12th gen. So I think that's wrong for a prediction. I mean, Intel did reverse that last year. ARM is, I still think, is a serious competitor to AMD or Intel, although, I don't think ARM quite operates at the same scale as AMD and Intel do. I think AMD is still the overall market leader in the server market at the moment. And the comment here, no, Apple Silicon has already surpassed Intel in 2020. That was true then. That's not true now. Yeah, they they came up close to parity on the 11th gen with the M1 Max chip, and I don't think the Pro quite made it there, but the Max did. And then 12th gen came out, and Intel reasserted itself as the leader. So that game of cat and mouse will probably go on for a while, but I think that it was a surprise to a lot of people that the Alpha Silicon performs as well as it does. Intel has delayed 7 nanometer till 2022, and that's still true as far as I know. I haven't heard any other announcements about 7 nanometer just yet. But the Intel server CPUs are certainly not competitive with the Milan architecture, and now they're having to compete with the Milan X. HPE this is talking about high performance computing is expected to shift to AMD's 1.5 exabyte or exaflops billion. That's a billion times a billion floating point operations per second. So, and that is being built for the Oak Ridge Laboratories supercomputer known as Frontier. That, of course, is a joint effort with HPE and AMD to build it. Now, AMD is bringing both their Milan CPU as well as their GPU, which is based on what they call AMD Indistinct. Now, that is a multiple module CPU with an inbuilt or GPU, excuse me, a multiple module GPU, meaning there's more than one GPU core, and a scheduler that's built into that chipset, which allows it to schedule workloads on both GPUs in order to run them in parallel. So, first time that's ever been done by AMD. And let's talk a little bit about that. So, AMD RDNA 3 didn't happen. That would have been if it did, that would have been graphics boards that would have been in the 7000 series we didn't see that. Now, there are, like the Indistinct, that is RDNA 3. So, I guess you could say, yeah, they did introduce it, but only on the server market. They didn't, they didn't do it for the desktop market. So, ARM, I wondered what would happen to Mali, and so far nothing has happened to Mali. But I will note that AMD does make an ARM-based chip of their own, and it has a hybrid GPU installed on that chip that is based on Volta right now, the Volta architecture. And that shows up in the Jetson AGX and Jetson AGX Xavier, as well as the Nano. That is being replaced. Nvidia made an announcement, I think it was back early October, maybe late September, that they have a new set of systems. Now, these systems are really designed for automotive, IoT, and AI applications. But the Jetson AGX and Jetson AGX Xavier are being replaced with a new hybrid Nvidia CPU that is ARM. It is ARM-based. I believe it's ARM version 9 architecture. And their hybrid GPU is based on the Nvidia Ampere architecture. Now, don't confuse that with Ampere, the manufacturer that makes ARM chips. This is Nvidia's Ampere architecture for multi-mode GPUs, and there are multiple GPUs on those. So, yeah, I don't know what the costs are yet. I haven't seen any retail pricing for it just yet. I still think, though, that NVIDIA will replace Mali. I mean, they certainly are moving that way. NVIDIA's RTX, this would have been the 4000 series. Our Hopper architecture, that never materialized for last year. I think this said they hadn't decided on TSMC or Samsung. I believe NVIDIA has decided on TSMC for this. And again, I don't know why they didn't do it, but again, you can't get the 3000 still yet. Even at this late date, you can get them, but yeah, you're going to pay a lot of money for them. They're way, way overpriced as far as their suggested manufacturer retail price are concerned. But yeah. Intel Xe graphics, the discrete GPUs, have been delayed until 2022. I'm just kind of curious on what's going to happen here. This is now approaching a 2-year-old design. Will Intel update this before they release it? Is that the reason for the delay? Is that maybe they're going back and trying to kick the performance up using newer technology? I mean, this is already a 2-year-old design. How well is it really going to compete with let's say that if and when NVIDIA releases their 4000 series GPUs and AMD releases their RX 7000 series GPUs, what's going to happen? So who are they actually going to compete with? As I said, there is a supercomputer by Cray that's called the Aurora, and that I assume is being delayed as well because it depends on that GPU to function. So not a good thing. Yeah, I think AMD last year in 2020 caught Nvidia by surprise, but Nvidia quickly reacted as they always do with the Model S and the TI in order to prevent AMD from holding any leadership positions in the GPU market. Nvidia's purchase of ARM is significant, but I wonder what the shakeout will be. I know there's bad blood between Nvidia and Qualcomm that's have its history. Same with Apple. That's also history. I don't know what the shakeout will be of this. If any, there may be none. I mean, corporations patch up things all the time, but yeah, it's just a matter of doing business. As far as the XE Max, when it gets released, will it matter? And it's still a question I have. Intel has stopped to tie their shoe twice now, but the other two guys haven't. Well, they stopped last year, so to tie their shoes too. So, I mean, interesting to see what happens in 2022. I think there could be either some really huge announcements or we stay the course of not releasing anything for 2022, depending upon how quickly the supply chain problems can be resolved. So software, I said 2021 will not be the Linux year, the Linux desktop. That was true. That didn't happen. Yeah, so Windows market share is continuing to decline. Now it's not like that. It's more a very gradual slope, but people are definitely moving away from Windows. I think Microsoft knows that. I think that's the reason why they released 11. Although it was kind of interesting that they put that many restrictions on it, so they're really forcing you to buy a new machine. Apple's Mac OS market share is, but again, it's not like that. It's more like, a slight incline that it's going up. The Linux desktop market share is growing slightly, but it's already very little to begin with. I think it was around 2.8% last year, at the end of last year, maybe 1.9. It's hard to tell. I mean, the numbers are so low. I mean, it's hard to tell if it's 1.9% or 2.8%. But right now, it's probably 3. It's just a little our margin. Now, that's the desktop market. In the server market, it's a different story. Linux completely dominates that platform. But yeah, as far as open source software, that indeed is increasing in market share. The reasons I gave for that were as you get to higher core counts on your CPUs, like Milan's 512 core machine. I mean, my God. If you're paying for your licenses on proprietary software by core, imagine what you're looking at a bill wise. If the last year you had a 64 and you had a 64 core machine and you're replacing with a 256 core, yeah, that's a heck of a jump. But yes, you are getting more processing power. You are reducing the rack size, but is it really that many times more? And yet you're going to pay 256 times the price per core, or 64 times the price per core. So yeah, you're looking at a larger bill. I think that is a driving force behind moving to open software, is to try to get it down onto systems which are free to use. I said edge computing will climb sharply. Yeah, it's not only climbing sharply, it's like that. It's almost vertical in the direction it's going. And again, that's because of the need for more and more devices at the front end, particularly with the faster phones and the faster networks. Fog, I thought, would follow along. Maybe not like that, but maybe it would take, it hasn't. There's a lot of interest in fog. And I think as the edge computing model clogs the network infrastructure, and it will, because I don't see anybody. I mean, the most expensive thing you could do is think about this: laying fiber optic transatlantic, or trans-Pacific, even worse. Yeah, that's very expensive to do. But yeah, I think fog will take off. It's the only way you can actually aggregate it down to a sizable chunk that would be able to use existing infrastructure. Especially if the prediction comes true that there's 1 trillion devices on the edge within 5 years. Whew, it's incredible. It's mind-boggling. Some closing thoughts. These are the ones that I had last year in white. So I'll just look at the red ones. Intel 12th Gen took back the gaming lead. But, it doesn't really matter if you can't get the chip, and supply chain woes are continuing to be a problem. 12th Gen Threadripper works, as I understand it, works great under Windows. I don't know. I haven't tested it. I don't have one thread because of the sales chain problem. However, Linux did service a problem. Wendell Holmes over at Level 1 Tech said, he was looking at the Threadripper problems on Linux. He was also discovering problems between different manufacturers of the system board. But the focus that I heard him talk about more than the other problems the system board problems always happens. That's just normal teething problems when you have a new architecture. But the Threadripper was kind of interesting because in his trials of it, if he turned on XMPP, which is the ability for you to use, if you have faster memory in your machine, the default clock of the machine is different. It's like for the memory is, let's say it's 2400 megahertz is the default clock in your BIOS. If you go in and turn on XMPP, then suddenly it looks at the memory, and if the memory is like a 3200 megahertz spec, it will reclock the memory speed. Well, when it does that, it also reclocks the CPU speed, and Linux treats that as an overclock. When the overclock bit is on, Threadripper stops distributing workloads based on type of core. It says, oh, well, all of these cores are now equal, and it just starts spreading the workload evenly across all the cores. Well, of course, that's not the thing that we really want. We want it to distribute based on the type of core, and that breaks down. I'm assuming that that's a bug, and that'll get fixed, no big deal. But it is interesting that and I know that Windows and Microsoft, the Windows people at Microsoft worked with Intel hand in hand to make sure everything was right, which is why it's working. I'm not so sure what the Linux guys did, though, but I don't know. So enough on that. So how did I do? I got 7 out of 30 out of 12 right. So 7 out of 12. That's a failing grade. Yeah, most of the predictions that I got right had spec problems. So there's a secondary problem there. Supply chain issues were a problem last year. I think that'll continue into this coming year. And the Intel delayed their discrete graphics card again. ARM did okay, but they're kind of easy to follow. They have a roadmap and it's pretty clear. They hold to it pretty well. I don't know what will happen now that Nvidia is involved, but I suspect they will hold to the same roadmap again. ARM, of course, doesn't fabricate their own chips. They just build designs that companies that have their own fabs or contract with third-party fabs build chips, not ARM. So Nvidia has not replaced the MacLeod chip yet. So, like I said, there's 2 models that are using the new Nvidia architecture. If I was a betting man, I would say, gee, Nvidia makes GPUs. Why would they use somebody else's in the ARM chips? So yeah, I just don't see that continuing on. So that's all I had for today. I hope you enjoyed this failure once again to try to predict with any accuracy for what's going on, but it's hard to gauge, market forces. And really, I think most of the problems that we had last year were market forces driven by the need for server tech, desktop tech in order to support a remote workforce. That was unplanned. And then the second thing was supply chain problems that were going to be the result of not having people at work at physical work in order to make sure that things are built, made, and boxed and packaged and shipped. And then once you did have it shipped, that you had the people at the docks that were receiving it, moving it onto trucks and getting it out distributed to the places where it needed to go in order to reach your hands. So yeah, the market chain problem is a big deal. As far as the fabricators are concerned of the chip architecture now, currently, TSMC manufactures, I think it's 97% of the CPUs manufactured worldwide, all in one place. and that would be in Taiwan. Taiwan just happens to be in the middle of an earthquake area. They have been known to have bad weather. They've also are in a political, they're in a contested political area as well. So to have all of our fabrication worldwide centered in one place is not a good idea. TSMC is currently building a new fabrication in Arizona. I don't know where else they are, but I know they're building one there. It's about a $12 billion complex. Now, generally you talk about fabs costing about $10 billion to build. So yeah, it's a pretty good sized facility. Intel is right next door physically, and they're building a fab facility there as well, both for themselves and to offer fabrication for third parties that want to contract with Intel as a fabricator. So you have two competitors that are right next to each other. There's also Samsung and TI that are building fabrication facilities in Texas. So it's going to be an interesting year. I know that I know that Intel is also building a fab over in Europe. So yeah, it's good to see this happening because to have it all in one place, not a good idea. I mean, we've seen fires and we've seen all kinds of things that have delayed production. Floods, for example, a few years ago that delayed the hard drive market. So yeah, we've already seen how that works out. It's not good to have all your eggs in one basket. So anyway, that's all I had for today. Hope you enjoyed this. Please like and subscribe. Hope to see y'all again real soon. Bye for now.